Hello everyone. In this lecture I shall discuss the Euler-Cauchy equation, both the homogeneous as well as the particular solution. The general form of a Euler-Cauchy equation of nth order is given like this, but our concentration is to solve it for second order. For n is equal to 2, this converted to a second order Euler-Cauchy equation of the form x square y double dash plus ax y dash plus b into y is equal to rx. So a and b are constant. Okay, a and b are constant. But you see, x square is multiplied with y double dash, x is multiplied with y dash. In general form, you see, x to the power n is multiplied with nth order derivative, x to the power n minus 1 is multiplied with n minus 1th order derivative. So likewise, now this rx here, this rx may 0, rx may not 0. Okay, if rx is equal to 0, then it leads to homogeneous case, and if rx is not equal to 0, then it leads to non-homogeneous case, right? It leads to non-homogeneous case. So once it is non-homogeneous, we have the complete solution, or the general solution is y homogeneous plus y particular, and your y homogeneous is yh is called the complementary function, right, denoted by yh or yc or cf, and then yp is your particular solution, or we call it particular integral, denoted by yp or pi. Okay, now to find the general solution, we have to first find the homogeneous solution. So for homogeneous solution, your rx is equal to 0, so you consider x square y double dash plus ax y dash plus by is equal to 0, and you put y is equal to, if we recall the previous case, right, y double dash plus ay dash plus by is equal to 0. Okay, you put y is equal to e to the power lambda x. The auxiliary equation becomes lambda square plus a lambda plus b is equal to 0. Solving this, it give you two values of lambda 1 and lambda 2. Okay, and there are different cases, real and distinct. Okay, real and distinct, and real and repeated, and complex conjugate in that way. Okay, so here likewise you put y is equal to x to the power m, right? So this implies your y dash is m x to the power m minus 1, y double dash is m into m minus 1 x to the power m minus 2. You substitute this thing over here. So this implies, if once you substitute it, x to the power m minus 2 and x to the power 2, it becomes x to the power m. Okay, so you are getting m into m minus 1 x to the power m, plus likewise x to the power m minus 1 and x, it is a m x to the power m plus b x to the power m is equal to 0. If you take common x to the power m, it will give you m square plus a minus 1m plus b is equal to 0. So now we are getting, this is your characteristic equation or auxiliary equation. So this implies you are getting m square plus a minus 1m plus b is equal to 0, and this is called the characteristic or auxiliary equation. Okay, characteristic or auxiliary equation. You see here, if you compare it the previous case, it is directly lambda square and it is a lambda, it is b, but here it is a minus 1. You see here it is a minus 1. In that way you can compare it. Now if you recall the solution in this case here, if it is real and distinct, okay, then y is equal to c1 e to the power lambda 1x plus c2 e to the power lambda 2x. Real and distinct case. If it is real and repeated case, then y is equal to c1 plus c2x e to the power lambda x. And once it is complex conjugate case, y is equal to, suppose here lambda is equal to alpha plus minus I beta. then here y is equal to e to the power alpha x c1 cos beta x plus c2 sin beta x. So this was the case here. This is for real and distinct, and this is for lambda is equal to lambda 1 equal to lambda 2 real. Then here second. Okay, likewise we extend the solution here. We will extend the solution here. You see here the complementary, this characteristic equation or the auxiliary equation, we may have the value of m. It can be classified into three categories: real and distinct, this is real and repeated, this is your complex conjugate. Okay, this is your complex conjugate. It is lambda is real and distinct. Distinct, lambda is equal to lambda 1 and lambda 2. Then in this case y is equal to y homogeneous is equal to, you see this is the base solution x to the power m. So we substitute here the value of m. We are getting m. Okay, m is real and distinct, so m is here m1 and m2. Okay, we have taken m, so here m is equal to m is m1 and m2, both are real and distinct. So homogeneous is x to the power m1 is a solution, x to the power m2 is a solution, and if you combine them, c1 this plus c2 this. Okay, so this is the solution under case 1. Okay, so now it resemblance to this, right? It resemblance to here this. Clear? Now in particular, if suppose here m is equal to, you are getting 2 and 3, then here y homogeneous will be c1 x square plus c2 x cube. In that way, this is the example. So under second case, what will happen? Here m is equal to real and repeated. So m is equal to m1 is equal to m2. So in this case, the solution is y homogeneous will be c1 x to the power m plus, secondly we have already 1x. You see here x is multiplied, here ln x will be multiplied, c2 ln x to the power m. So we can write it c1 plus c2 ln x to the power m. This is the idea. Okay, so you see here c1 plus c2x e to the power lambda x. So it is like this. Now in particular, if I take, suppose m is equal to 5 and 5, then what will be your y homogeneous? It will be c1 plus c2 ln x to the power 5. Okay, this is the idea. Now coming to the third category, it is, you say, complex conjugate. Okay, m is equal to, suppose, alpha plus minus I beta. Complex conjugate. Then what is the solution? In this case, if you think of alpha plus I beta and alpha minus I beta in line with this, right, then what will happen? Here y is equal to, y homogeneous is equal to c1 x to the power alpha plus I beta plus c2 x to the power alpha minus I beta. Okay, but if we want to make it free from I, okay, if we want to make it free from I in this power here, okay, free from complex number, then complex number I, that means your y homogeneous in this case will be, and one more thing, if you recall this, it is e to the power alpha x c1 cos beta x c2 sin beta x. In this line, it will be x to the power alpha c1 cos beta ln x, okay, plus c2 sin beta ln x, right? So we should concentrate on this because this is free from the complex number. So in that way, you can have the homogeneous solution under three cases. Okay, you just compare this with this and you just remember it, right? What is the auxiliary? You may directly write the auxiliary equation, then you classify it is under which category, and accordingly you solve it. Next, to find particular solution, YP. Okay, so here x square y double dash plus ax y dash plus by is equal to your rx. Okay, so first you have to divide this. Right? So this is y double dash plus you say it is px y dash plus your qxy is equal to you say some your capital Rx. Okay, now you see you should ensure that this coefficient should be 1. Okay, this coefficient should be 1 and use method of variation of parameter. Right, you have to use the method of variation of parameter. Right, use method of variation of parameter. And this method of variation of parameter is again one of the powerful aspects. Suppose you see y double dash plus ay dash plus by is equal to tan x, sec x, cosec x, okay, etc. e to the power x, right? I am talking about constant coefficient. The constant coefficient. Then what will happen? These are not resemblance to their derivatives. Okay. Then your previous method will not work. Method of undetermined coefficient will not work also. Right? Method of undetermined coefficient. Also operator method may not work. Okay, may not work. So in this case the only approach is the variation of method of variation of parameter. Okay, we have to know the method of variation of parameter will help you. Method of variation of parameter will help you. Okay, method of variation of parameter, and which will be discussed in the next lecture. In the next lecture I will discuss it. Right, together with this type and together with this Euler-Cauchy, I will discuss the method of variation of parameter in the next lecture. Coming to the alternate approach, you have this is the Euler-Cauchy equation. So it is y double dash means what? D square y by dx square. Now I want to convert it to the other variable, means if I put x is equal to e to the power t, then your t is equal to log x. Then what will happen here? Now dy by dx will be here dy by dt into dt by dx. Okay, so this is equal to dy by dt. So what is dt by dx? You see here, what is dt by dx? It is derivative of log x is 1 by x, right? So this means if you multiply x here, x into dy by dx will be here dy by dt. We see now this variable coefficient, okay, now reduced to here dy by dt constant coefficient. Accordingly what we are getting? Accordingly, if you simplify, you will be getting x square d square y by dx square. It will be d into d minus 1 into y. So here it is, I can write it d by dt of y, and if I write it d, it is here d of y. Okay, but d of y here. So now in this case, what is my d? I can write it d square plus ad plus by is equal to 0. Okay, what is your d here? D was here d by dx, but here we convert into d by dt here, and accordingly it will be this. Okay, now this is your d into d minus 1y. Now if you substitute all this thing here, okay, if you substitute all this thing here, right, it will be here d into d minus 1 y plus ady plus by is equal to here, this rx will be, x is here e to the power t, rt, it will be a function of t now. Okay, so that means you are getting d square plus a minus 1 into d plus by is equal to 0 is equal to your RT. Now you see what is the auxiliary equation now? The auxiliary equation here is for homogeneous solution. For homogeneous solution, your auxiliary equation is d square plus a minus 1 into d plus b is equal to 0. Okay, b is equal to 0. So is it not resemblance to your this previous case? Now it is resemblance to your this, right? It resemblance to your this m square plus a minus 1m plus b is equal to 0. So if I again put y is equal to, okay, if I put y is equal to here e to the power lambda x, can I not get it in the same way? Lambda square plus a minus 1 lambda plus b is equal to 0. Accordingly we will have the solution. So this solution here will be in line with this. So this solution here will be in line with this. Okay, so this solution here will be in line with this constant coefficient, right? This is for constant coefficient. Now it reduced to constant coefficient as we discussed earlier. So the particular solution, so in that case for particular solution the operator technique will help, right? We use operator technique or we use method of undetermined coefficient, and finally your t need to be replaced by ln x. Okay, t need to be replaced by ln x. So this is the idea, right? That means it has an independent approach. By putting y is equal to x to the power m, we have an independent approach, or we can convert it to the previous case, right? So the independent approach will be better. Okay, independent approach will be better. So let us discuss some examples. So we see this is a Euler-Cauchy equation. This is an Euler-Cauchy equation. So now we put y is equal to x to the power n. Okay, the auxiliary equation becomes what is your a? This is your a is minus 4 is m square plus a minus 1m plus b is equal to 0. This is your b. So that means your m square minus 5m minus 4 minus 1 minus 5m plus your 6 is equal to 0. Okay, this is the auxiliary equation. If you simplify it, so that means here m is equal to 2 and 3. So therefore y homogeneous will be c1 x to the power 2 plus c2 x to the power 3. So this is the answer. Okay, now alternatively if you approach the previous idea, alternatively as I have mentioned, put here x is equal to e to the power t implies t is ln x, and accordingly x square y double dash is d into d minus 1y xy is dy. Okay, and if you substitute with what is your d is your d by dt, then it will be converted to d square. You see here it is d square minus d into y minus 4 dy plus 6y is equal to 0. So that means if you simplify it, it is d square minus 5d plus 6 y is equal to 0. Now if you put y is equal to x to the power, e to the power lambda x, okay, the auxiliary equation becomes lambda square minus 5 lambda plus 6 is equal to 0. So that means lambda is equal to 2 and 3. So what is y homogeneous here? C1, it is e to the power 2x plus C2 e to the power 3x. Now what is the value of x now? The value of x is now, the value of t is now ln x. So it is t in terms of t now. Okay, so this is equal to here C1 e to the power 2 ln x plus C2 e to the power 3 ln x, and you can write it C1 e to the power ln x square plus C2 e to the power ln x cube. This e and ln are inverse, so this will give you C1 x cube plus C2 x square plus C2 x cube. So y homogeneous is this. So this is the idea. Okay, So this is your answer. You see, the straightforward approach is easy, is not it? So this is easy. This is easy. The straightforward approach is quite easy. Okay. However, the thing is that if non-homogeneous equation is given, then this will help you. Okay. This will help you to find the particular solution. So this approach will help you. This approach helps to solve particular integral, solve pi, or else we use for pi. So here for pi, if at all is asked, then this pi can be solved, particular solution can be solved. We have to use method of variation of parameter. Okay, so this is the difference. So here a different method is used, and here the same method will work. So this is the difference only. However, I recommend to use the first direct case. Coming to example 2, you are asked to solve this. So I prefer the direct method. Put y is equal to x to the power m. We may have the details of work. The auxiliary equation becomes here m square plus a minus 1 minus 3 minus 1 m plus b equal to 0. So this is your a here, is not it? A minus 1 plus b. So that means m square minus 4m plus 4 is equal to 0 implies m minus 2 whole square is equal to 0. So that means m is equal to 2. m is equal to 2 repeated twice. So this is a case of real and repeated. So therefore y homogeneous is c1 plus c2 ln x square. So this is your answer. Coming to one more example. So coming to example 3, the solution is putting y is equal to x to the power n. The auxiliary equation is here m square plus a is here 1 here plus 1 minus 1m plus b is 4. So that means m square plus 4 is equal to 0. So that means m is plus and minus 2i complex conjugate. I can write it 0 plus minus 2i. So y homogeneous is e to the x to the power alpha. Okay, c1 cos beta ln x plus c2 sin beta ln x. Beta is here 2. Okay, so that will be c1 cos, we can write it ln x square plus c2 sin ln x square. Okay, sin ln x square. So this is the answer. Coming to one more example. So coming to the solution here, we can write this equation as x y double dash plus y is equal to 0. This is not in the form, we multiply 1x. Okay, so we multiply 1x x square y double dash plus x y dash is equal to 0. So that means I can write it x square y double dash plus x y dash plus 0y equal to 0. So what is the auxiliary equation? The auxiliary equation is here m square plus 1 minus 1m is equal to 0, is not it? So this implies here m square is equal to 0. So what does it mean? M is equal to 0 and it is repeated twice. It is a case of real and repeated. Therefore y homogeneous is equal to c1 plus c2 ln x to the power 0. So this is simply c1 plus c2 ln x. So this is your answer. Okay, this is your answer. Coming to next example, where we have the non-homogeneous equation is given. You see here, this is a non-homogeneous equation because the right hand side Rx is not equal to 0. Now coming to the solutions, as we have not discussed the method of variation of parameter, I want to go back to the previous method. Means I put here x is equal to e to the power t. So here so this implies my t is equal to ln x, and what is my d here? D is equal to d by dt here, and my dy and my here x y dash is dy, x square y dash y double dash is d into d minus 1 into y accordingly. So now equation 1 becomes here d square minus plus minus 2 minus 1 into d minus 4 is here x to the power 4 is e to the power t whole to the power 4. You see, this is the same line of the auxiliary equation. Okay, this is the same line of the auxiliary equation as we discussed in the direct case. So this implies 1y is here, 1y is here. So this implies here d square minus 3d minus 4y is equal to e to the power 4t. Okay, you see, e to the power 4t. This is a non-homogeneous equation. Now what is my homogeneous solution? So it is for constant coefficient. It is the auxiliary equation here is e to the power, we are putting here y is equal to e to the power lambda x we are putting. So the auxiliary equation will be lambda square minus 3 lambda minus 4 is equal to 0. Okay, so that means here lambda is equal to minus 1 and 4. So here y is equal to c1 e to the power minus x plus c2 e to the power 4x. So this is your homogeneous solution. It is in t, it is in t. We have converted to t here. Okay, it is t here. So now if you substitute t is equal to ln x, so it will give you c1 x to the power minus 1 plus c2 x to the power 4. Okay, so why homogeneous is this? You can compare it with the direct solution. You compare it with the direct solution. Okay, we are getting this, right? We are getting this. Now for the particular solution we have, so for the particular solution we have here d square minus 3d minus 4 y is e to the power 4t. So that means here y particular will be 1 by d square minus 3d minus 4 e to the power 4t. What we have to do? We have to replace d by here 4. Okay, provided your denominator is not equal to 0. So what we are getting here? So we are getting, I substitute 4 here. It is 1 by 4 square minus 3 into 4 minus 4 e to the power 4t. Okay, if I simplify it, it is, so you see here the denominator is 0. Okay, you see here the denominator is 0 here. The denominator is 0 here. So what we have to do? We have to multiply one t in the numerator. Okay, and we have to differentiate the denominator. Differentiate of derivative of d square is 2d minus 3d is minus 3 e to the power 4t. Okay, so now we replace d by here 4. Okay, so what we are getting? T by, it is 8 minus 3 e to the power 4t. It is here t e to the power 4t divided by 5. Now you can substitute the value of t. Okay, so what is the value of t here? T is here log x. So that is equal to, now what is the value of t here? T is here log x. So this is equal to, I can write it log x e to the power 4 log x by 5. So that is equal to, I can write log x e to the power ln x to the power 4 by 5. So e to the power ln is 1 here. So this is equal to x fourth log x by 5. So this is my y particular solution. So therefore the general solution is y is equal to y homogeneous plus y particular is equal to c1 x to the power minus 1 plus c2 x to the power 4 plus x to the power 4 ln x divided by 5. Now coming to the last example, you can also use the method of undetermined coefficient here. Okay, also you may use method of undetermined coefficient, right? This can be also used. However, this operator is simple here. So now if you solve it, here put y is equal to e to the power, x is equal to e to the power t, implies t is equal to log x. As usual, what we are getting? It is d square minus dy plus xd, plus it is dy plus it is here dy. Okay, plus y is equal to here sine is equal to here sine ln x square. X square is e to the power 2t. Okay, so what we are getting? We are getting d square plus 1 into y is equal to 0. This and this cancelled. So d square plus 1 is equal to, the right hand side is sine ln e to the power 2t, means sine 2t only. Sin E and ln is 1, so it is sin 2t only. Okay. So now coming to the homogeneous solution. The auxiliary equation is, lambda square plus 1 is equal to 0. So this implies lambda is plus n minus I. So this implies here y homogeneous is equal to C1 cos t plus C2 sin t. If you substitute the value of t here, we are getting C1 cos ln x, okay, ln x plus C2 sin ln x in terms of x. So this is my y homogeneous. Now coming to y particular. For particular solution we have d square plus 1 into y is sin 2t. So that means your y particular is 1 by d square plus 1 sin 2t. So here d square is replaced by minus of a square. A is here, 2 here. So d square is replaced by minus of 2 square provided denominator is not equal to 0. So I can write it 1 by minus 2 square plus 1 sin 2t is sin 2t by 3 is equal to sin 2t by minus 3. Now substitute the value of t here. So this is equal to sin 2 ln x by minus 3. So therefore the general solution is y is equal to y homogeneous plus y particular is C1 cos ln x plus C2 sin ln x plus, I can write it minus here, sin ln x square by 3. Okay, so this power becomes the power of this x here. So this is your answer. Okay. So now to conclude, if you are given a Euler-Cauchy equation, you can put y is equal to x to the power m, and likewise you directly solve. The auxiliary equation is m square plus a minus 1 into m is plus b is equal to 0, and accordingly you solve it. Otherwise, and if you solve by this method, you have to use your variation of parameter to find particular integral, to find particular solution, right? Or you can come back to the previous method, right? Or you can come back to the previous technique, right? For constant coefficient, as we discussed earlier, constant coefficient. Here this directly you can find particular solution, you can find directly but here this method of variation of parameter we will discuss in our next lecture, because there are some classes of problem which are not solvable by this direct method. Okay, so here also we use method of variation of parameter. If your Rx is your tan x, sec x, e to the power x, like that, some complicated functions are there. Okay, so now the video is getting lengthy, we should close it here. If you feel this lecture is useful and interesting for you, please like and subscribe to this channel. It will boost my motivation so that I can upload the subsequent lecture for your benefits. So thank you all. Have a nice day. Once again I thank you all.